In this lesson, we will be going over how to use primary trig ratios to solve for unknown angles in triangles. So the steps for this are very similar to what was covered in the last lesson. So you're still going to be using the primary trig ratios, which remember, you can remember which ones are which using SOHCAHTOA. But now, instead of solving for an unknown side, we're going to be solving for an unknown angle. So when you're doing this, you're going to set up the ratio the exact same way that you did in the last lesson. So for example, in this triangle here, you can see that the angle we're looking for is this one. Remember, this is called theta. There we go. So this is called theta. And the sides that we have here are the adjacent side and the hypotenuse. So as you should recall, using SOHCAHTOA, if we have our adjacent and our hypotenuse, it means that we would use the cosine ratio. So cosine theta is equal to adjacent divided by hypotenuse. So cosine theta is equal to 16 divided by 34. Now, when we were solving for sides, our unknowns were one of these two numbers. Now, our unknown is this angle. So in order to solve for this angle, we need to isolate this angle. And to do that, we need to use the inverse of the cosine function. And to do that on your calculator, what you're going to do is you are going to click on most calculators, second function, and then right above the cosine button, you'll see there's a cosine inverse button. And you're going to put that in, and then you'll do cosine inverse of 16 over, or divided by, 34, which will give you your resulting angle. So in this case, 61.9 degrees. If we look at the next example, here, again, the angle that we're looking for is x. So we need to label the sides that have been given to us. This side, remember, shares a side with the angle. So this would be the adjacent side. And this 12 feet is across, so this is the opposite. Now, the ratio that uses opposite and adjacent is tan. So that we would have tan of x is equal to the opposite over the adjacent. So tan x is equal to 12 over 19. And in order to isolate x, we need to use the inverse of tan. So we are going to take tan inverse of 12 divided by 19. So tan inverse, second function, tan, 12 divided by 19, which gives us a result of 32.3 degrees if we round. So that would be the measure of angle x. One more example here, and in this triangle it's asking you to find the measurement of each angle and to round all of your answers to the nearest degree. So first you would want to start with one of your angles. So I'm just going to choose A, doesn't matter which angle we start with, and I'm going to label the sides according to side A. So here I have my, well, I'll start over here with the hypotenuse. That's usually the easiest one to label. And this 5 inches is sharing a side, forming that angle. So it will be the adjacent, and the 12 is the opposite. Now what you'll notice here is that you have all 3 sides. So you can actually technically use any of the 3 ratios. I'm just going to pick one, doesn't matter which one you use. I'm going to use sine. So sine of A is equal to the opposite over the hypotenuse. like I said, if you chose to use tan, you could because you have opposite and adjacent. If you used cosine, you could because you have adjacent and hypotenuse. Any of the three trig ratios will give you the same answer in this scenario. So here, sine of A is equal to the opposite, so 12 over the hypotenuse, which is 13. And in order to solve for A, I'm going to use sine inverse of 12 over 13, 12 divided by 13. So on my calculator, sine inverse of 12 over 13. So 67, rounding to the nearest degree, so just 67 degrees. So this angle here is 67 degrees. Now it wants us to find all the angles. So we know that angle C is a right angle, so that's 90 degrees. Now you could use trig ratios again to solve for side or angle B, but what we also know is that in a triangle, the total of the three angles should equal 180 degrees. So in order to solve for side B, we need to know what this angle would be, so that angle B plus 90 plus 67 equals 180. So I can use subtraction. 180 degrees minus 90 degrees minus 67. And that will tell me what's left for angle B. And when I do that subtraction, I get an angle of 23 degrees. So B is equal to 23. So A is 67, B is 23. Oops. Now, there's also a little bit of vocabulary that you need to know when working with triangles, and these are the terms angle of elevation and angle of depression. So, an angle of elevation is an angle that's formed when you're going from the horizontal upwards. So common examples of this when you're working with word problems are usually to do with an angle that's going from the ground or somebody's eye level and then looking upward. An angle of depression, on the other hand, goes from the horizontal, so here, but usually or looking downward, and usually it's eye level looking down or looking down from above. So elevation goes from the ground up and depression goes from the top down. Now these are always equal. So if you had an angle of elevation here that, let's say this was 30 degrees, then this angle over here, the angle of depression related to this, would also be 30 degrees. So if we look at this diagram here, it says we have a plane that's flying 40,000 feet above the ground, and the plane is 100,000 feet diagonally from the runway where it will land. Determine the angle of elevation from the ground toward the flying plane overhead. So this is an angle of elevation because we're going from ground upward. So we're going up toward this line. So when we're solving for this, it's the same thing. This is the angle we're concerned with, so we're going to label our sides according to that. Again, the easiest one, oops, is the hypotenuse, if I can spell it correctly, hypotenuse. And the other side we know is across from this angle, which is the opposite. And the trig ratio that uses opposite and hypotenuse is sine. So sine theta equals opposite over hypotenuse, which means that sine theta is equal to 40,000 over 100,000. And in order to solve for theta, I'm going to use sine inverse 40,000 divided by 100,000. Sine inverse, 40,000 divided by 100,000. I get an angle of 23.6 degrees. So that is how to solve for an angle using primary trig ratios.